you need to come up with an area, at least for us, of a new application, an
Right.
application that opens up a significantly new TAM for, addressable market for the OEM. And for that, the second piece was like, we need to actually be very involved and understanding what are the dynamics of the markets for the customer, right? I remember when we sold to our first customer, Toyota, we built our own car. Yeah, selling to the Department of War is not easy. There is a lot of need. So you need to first identify where in this whole chain you're the most valuable. You really need to identify customers that, like, if you walk away from the deal, they will be like, no, come back, right? You want those customers, especially in the early stages of a company. You want those customers where you're like, you walk away, they'll be like, no, I'll pay you more. Let's stay, and let's just do this, right? So, so initially go wide, but very soon you need to narrow to say, okay, like, what are the 4 or 5 things I'm going to do?
But when do you take a step back and then try and analyze, okay, do I want to increase the scope of my offering?
For example, somebody came to us and said, hey, I want to build this 50-foot statue of George Washington for America's birthday, 2050 birthday. And it's like, this is a market we have never been to in.
Yeah.
But, okay, that's an interesting project. It's a small project,
Yeah.
but I would love to do that to see, okay, what does the entertainment and architecture market look like? So we always have a pulse on what might be the next thing.
So, Ed, thank you so much for taking the time.
Thank you. Thank you for having me. Excited to have this conversation.
As you know, that at Protean, we are building operating infrastructure to support early stage businesses that operate in the industrial automation space. And one of the ways we do that is by learning from serious hardcore operators like you. And, so I'm very, very excited to dive in. But before getting to very specific actionable insights, I would love to know a little bit about your story, your journey leading up to Machina Labs, and if you always wanted to be an entrepreneur.
Oh, absolutely. No, actually, the answer to that is no, I didn't want to be an entrepreneur. I am an engineer at heart, right? Like, I love building things, I like making things. But, one of the things very early on I learned kind of the harder way was like, I really wanted to be part of a problem that I really feel passionate about. And I think it
Mm.
needs to be solved. That ended in me actually quitting school a few times and, go on extended leaves from school to just go work. I remember I got one of my early internships with Sony Electronics, like first year in college.
Wow.
And I was so fascinated by what they're building. And I felt like I'm going to learn way more by being in the industry than being in the school. So that basically left the school and spent some time, 2 years doing that. And then, went back to school again, but then had another opportunity at Microsoft and Google. So ended up doing this over and over again, where I really wanted to be part of really learning and understanding big problems and being able to be part of that solution. So no, I didn't want to be an entrepreneur. I always wanted to be solving problems.
Right.
And I think entrepreneurship came about when there was a problem that I was really passionate about and nobody was solving it, at least the way I thought it should be solved.
Right.
So natural progression was to become, an entrepreneur and starting the company. But even back then, I wasn't thinking about it as a company. I was thinking about, okay, hey, here's a very important problem to solve. It's exciting to solve. I'm in a good position in my life to be able to solve, and I have a good group of people around me that are also as excited about this. So let's just do this, and things will work out. And most of the time, it did, right? So that's kind of my journey into entrepreneurship. But I didn't start in manufacturing and automation. I
Right.
started in actually AI and software space, both academically and early years of my career, like companies like Google and Microsoft, until one day I ended up taking a tour at SpaceX factory. This is more than a decade ago.
Wow. Okay.
And I was just mesmerized. I was like a kid in a candy shop. I was like, it was like, oh my God, these guys are actually building a rocket and they're saying that they want to go to Mars. And that's just such an exciting mission and such a big problem to solve. So that, made me want to quit basically the software world and the artificial robotics world and join SpaceX early on as a software and control engineer. But that's when I started to get familiar with some of the challenges we had on the manufacturing side. I saw how significantly takes longer to build hardware products. And you have to almost build a factory every time you want to build a product in a hardware world. And
How big was the company then, SpaceX?
at the time, I think I remember my badge number was maybe like I don't exactly remember, but like maybe 600. So that means like there were
Right.
600 people before me. I think when I left, a few years later, I remember the badge numbers were around like few thousand. So like
Yeah.
company significantly grew from there, like maybe almost 10 times increase in size. But yeah, it was still early days. So you could kind of do a lot of things. As a software engineer, you could actually, get exposed to the manufacturing side, to the automation side, end up working on some of our inventory solutions, on some of our manufacturing equipment. So, got the wide exposure. And then from then, I have been in this manufacturing space, working on the problem that I think it's one of the biggest problem manufacturing has, which is like, how do you build a factory that is not custom built for a product? How do you build a
Right.
factory that in the morning can make launch vehicle products and in the afternoon can make, aircraft products and at night can make auto products? So I did a detour in additive manufacturing. After
Mm.
SpaceX, I joined part of the early team, founding members of a company called Relativity Space,
Right.
where we were building a very large envelope metal 3D printer to build rockets, launch vehicles in a significantly faster way using 3D printing. After a few years there, I started Machina Labs to more fundamentally focus on how do you build factories that are easily flexible, easily can change from one product to another, from one material to another.
So if you could just double click on what Machina Labs really is and what does a typical facility look like? It's
Yeah.
very exciting that you're talking about building product A in the morning to building product B in the evening and probably C in the afternoon. So very, very curious as to what it looks like.
So Machina from the outside is a metal structures manufacturer, right? So
Mm.
basically you come to us to say, hey, I have this advanced metal structure, be it airframe of a missile, be it a panel for a car, be it a fuel tank for a UAV. You come to us and say, hey, I want to build this advanced metal structure, and can you guys help us first develop it and then later on go to production with it? So we are a manufacturer, we're a metal structures manufacturer. But once you come to our facility, you will see a very different facility than a traditional metal structures manufacturer.
Hmm.
Most of manufacturers, they have this view of an assembly line, right? Where
Right.
things from start one end, and then you want to move the product as soon as possible from feedstock to the final product. Everything is in series, and each operation just needs to have as fast as possible to have a tack time that's as fast as possible. That way, you improve your efficiency. You come to our factory, it's very different. First of all, there's a whole bunch of different products, right? You go to our area where, we call them post-processing areas, the area that before that, the product goes to the customer. You will see 6, 7, 8 different products being manufactured at the same time, right?
Hmm.
Different designs. This is not a common scene in a metal manufacturing where you make the same thing over and over again.
Right.
Then it's also not very much like assembly line. We have these robotic systems that each of them can be programmed to do different operation. So it's more of a matrix operation in industry call it, but basically a cell-based manufacturing where instead of
Hmm.
having assembly line, you have a workstation, robotic workstations that we design and manufacture. We call them robo craftsmen. They're doing different types of operation on different material, different geometries. And in our factory number one, we have like 8 to 10 of these operational at each point in time. And, one of them might be working on a missile product, another one might be working on an aircraft product. So they work independent of each other, almost like you can think of them as like a little robotic team of craftsmen working on
Right.
a different product. And so, yeah, it looks very different. It doesn't look like an assembly line. You see a huge diversity of products, and pretty much all this stuff is being done by robots. The other thing you will notice if you come to our facility, you know, robots are working, and not a whole lot of people running around moving things around. We still have a good amount of technicians, but when the robots are running, you don't see them around them, right? Like robots are autonomous. When they start running, they're pretty autonomous. So pretty high productivity also in our facilities for the amount of employees we have.
Very cool. So, obviously you talked about flexibility and your LinkedIn actually says that you're building a high mix, high volume future with robots and AI. So, for someone who's not very familiar with what high mix and high volume actually means, could you tell us what it is?
Yeah. So high mix volume is equivalent of the pictures you see in sci-fi films and sci-fi movies, where there's a huge design diversity. So high mix means increased number of designs, and high volume means you have a lot of them being manufactured. Today's world, in contrast, is low mix, high volume, I would say, right? Where every car kind of looks the same. every building looks the same. So there's not a whole lot of design variety, but like we repeatedly manufacture the same thing. And actually the successful things are the ones that we repeatedly manufacture. A successful car is a car that you make 1 million of it a year and everybody would love to buy it, you know? Um, so this is the paradigm that's existent today. I think the future is not going to be this boring, right? We're not going to have the same products over and over again. In the future, we're going to have huge design variety. We're going to be more expressive with our physical products. They're going to be multitude of vehicle designs, air taxis, launch vehicles, satellites. So each building will look different, and we would love to enable that. But the reason it's not enabled is because, manufacturing today has a huge economies of scale problem, meaning that, you need to have a factory that makes one thing over and over again for a very long time before it pays back for itself,
Yeah.
right? So the moment you can make a factory that can easily switch from a design to another, then you're going to solve this problem of high volume but low mix, and you can add more mix into it. And I think it's going to make the world more interesting. But even today, there are like industries that have a huge requirement for high mix, right? You look at the defense industry,
Right.
not a single defense system or a weapon system is manufactured more than a few thousand a year, right? But then we have like 50, 60, 70 different defense systems that our military, for example, uses, right? So how do you build those things without having to, make a huge expensive factory that's designed to make 1 million of the same thing? So it's a problem that we have in, for example, in defense industry today, where we are already high volume, high mix,
Yeah.
but it becomes very expensive. That's why a fighter jet costs $100 million, right? Because you make a few of them, but they're not enough volume to needed to justify a giant facility, and then bring the cost of the end product low enough because it amortizes over that cost, right? So it's a problem we already have in defense, but I think every industry eventually will be more high mix than it is today.
Yeah. And I love your point of view on some of the industries that have sort of like a consumer angle as well. So for instance, you obviously talked about how consumers would like different types of parts within, say, a car, for instance, right? And you post about it on LinkedIn and social media anyway, right? And it's very exciting. So I just wanted to understand that in a world where you can actually achieve scale in so many forms and shapes, how did you land on this specific segment? Because you could have done something else as well, something which is low mix. So why high mix in specific, and how did you land on that decision primarily? Like, what were your steps?
So I think honestly, the question of why high mix is more of a philosophical question. Is like, where is the future, right? I truly believe future is high mix, right? Like, I think, you know, if any industry that enabled high mix, we've seen that happening, right? Like, for example, look at the software world. Like now in your
Right.
phone, there was a time where, everybody was using the same operating system, same set of software, even using supercomputers to do the same operations over and over again. But now we all have phones, and there is myriad of apps that you can download and put
Yeah.
on your phone that like, I don't even know, there's like so many apps in App Store that, like, you cannot even go through all of them, right?
Yeah.
In the software world, the moment you enable this high mix environment where anybody can get whatever they need, and it doesn't need to be the same as something that everybody else needs, right?
Right.
The industry usually moves toward that, more enabling that high mix. And I think this is a future that also exists for the hardware. So at some point, we need to solve it. At some point, we need to get to a point where we enable high mix, because I think fundamentally, as human beings, we want to be expressive. We want to
Right.
actually have myriad of designs out there that meets different types of needs. So me personally, going to SpaceX and some of the other hardware companies, I think the biggest shock for me when I went from software was like how slow it is to develop things.
Yeah.
That's the reason why there's not a huge mix. You
Mm.
look at a company like SpaceX is 20 something years old. Now it's not a startup anymore. It's about to go IPO, obviously. But
It's so hard to believe that, though.
yes, yeah, but they only have two, because also they only have two launch product
Right.
families.
Yeah.
There's only a Falcon family and there's a Starship family, because it's so hard to
Exactly your
enable high
point.
mix,
Yeah.
right?
Yeah.
But if they could, they would. They would have tried many different products. They would have moved
Yeah.
much faster, right? But they can't. So I think it's a general need, both on the human level, but also I think on the industry level, to be at a cost-effective point. just the question was like, how do we enable it? What technologies do we need to develop so that high mix is actually cost effective and it doesn't cost, a lot of money to, to add a new design or enable a new design?
Yeah. And some of the, like, just talking about some of the industries that you're working with, I looked at your website and they are some of the most interesting, but also toughest sectors to work with, right? Automotives, for example, and defense, right? So let's talk about your strategy, right, around these two sectors specifically, because a lot of the founders actually end up working with automotives because they are more open to automation, right, in general. In fact, the IFR reported that the number of industrial robots that were actually sold in the United States and actually world over were the highest for the automotive industry, right? And
Yeah.
so, but this industry is a multi-stakeholder industry. It has tier one, tier two suppliers, OEMs, SIs, or system integrators. And so, where do you specifically fall in the value chain? And how did your first, interaction or even sales to the automotive customer actually go?
Yeah. No, so this is kind of like one of the hardest pieces of selling into these industries that are giant, right? Like I
Right,
think go to market. How do you figure out how to sell to them, right?
right.
I think at the end of the day, the kind of the cliche answers comes down to revenue, right? Like
Mm,
revenue profits. Like what kind of a
right.
margin do you enable, what kind of a revenue increase do you enable? Now, so it's either on the cost side or on the revenue side. A lot of automation solutions that are incremental, they're on the cost side.
Mm,
So it's an incremental addition to what, a automotive OEM does. And if it's compelling enough, then, you can sell it. For us, it was a little bit different because we
mm.
were such a fundamental change in terms of manufacturing that, it was not incremental. So it was not easy to go sell to automotive. We're like, hey, instead of making panels this way, start using,
Yeah.
our technology and make it our way. And they were like, oh, that's such a huge change. I don't know how to think about that. So I think from our perspective, given that it was a fundamental change, there were a few things that was very important. One is you need to come up with an area, at least for us, of a new application, an
Right.
application that opens up a significantly new TAM for, addressable market for the OEM that they were not enabled to do before us, right?
Mm.
And for that, the second piece was like we need to actually be very involved and understanding what are the dynamics of the markets for the customer, right? Almost you have to be able to really put ourselves into their shoes, know the market really well, almost be as passionate about their products
Yeah.
as we are about ourselves. For us, going to automotive, we had to not only figure out a new area of TAM for them expansion, but also we need to really put ourselves in their shoes and almost be as passionate about their products and their customers as much as they were. I remember when we sold to our first customer, Toyota, in the automotive, first large customer. We actually work
Yeah.
with few brands, but first large customer. We built our own car, like using technology, and it sits down here. We've like actually rebuilt a whole car, all the panels using our technology so that they can come and see it real. And they wanted, I
This
remember
is crazy.
early meetings that we had with our champion and their executives was like, he was like, these guys are like one of us. They know they love cars. They even built their own cars. You can go see. Like they really care about this. They understand this market. They go to every show that we go. I used to go to these SEMA, which is aftermarket show for automotive.
Yeah.
So I really knew and our team knew the custom automotive market. So when we pitched a product that is enabled in custom automotive market with our technology, it felt genuine. It felt like somebody who
Mm.
actually cares about these OEMs, who understands what they want. And we were. I mean, I'm a car guy, right?
Yeah.
I was actually passionate about this product. So it's a product I would have bought myself, and that's why we built the car, right? So I think, you need to really be able to show that, significant increase in value for them, either in terms of savings or in terms of revenue in a very tangible way. And that means you need to just be almost in their shoes and you need to
Mm.
care about their customers and their products as much as, they care about them.
Yeah.
And then at that point, I think the sales becomes a little bit easier. That being said, sales cycle, even once you get the sign up and be like, okay, good, you're looking at 3-4 years, right? So like you need to also develop a huge kind of alignment in terms of roadmap. If you look at us, most of our customers invested in us, right?
Right.
Because we wanted to develop this 4 or 5 year roadmap. it's not a quick software sales where like, oh, tomorrow we enable it for you and everybody will use it. It's like, no, we are changing your manufacturing method. We are adding a new market to your customers and what you can sell. So this is a 4 or 5 years. Let's understand that it's 4 or 5 years. Let's align on 4 or 5 years. That means maybe you need to invest in us. That means we need to meet with multiple teams
Yeah.
within your company to enable this. And it's a long-term journey, but hopefully a journey that eventually unlocks a very significant value for them and for us.
That makes sense. And so when you work with a client right now, you manufacture in your facility, or there's an option for the client to work at their own facility?
We've done both.
Okay.
So we do operate our own factories. And when, for example, we work in defense,
Right.
that's the preferred mode of operation because
Okay.
defense companies and OEMs are, integrators and they want tier one suppliers to make the metal structures for them.
Right.
But for example, when we were working with automotive,
Yeah.
we were exploring potentially a co-location where our technology and our mini factory is inside their factory, right?
Yeah.
Because they're much more involved with manufacturing. And actually, there's a lot we can learn from them, right? A company like Toyota has created the language around how manufacturing is done. We're talking about Toyota production system, Kanban, Kaizen, right? All these things that every other company kind of like uses as best practices developed with Toyota. So in those situations, we actually have presence with them in their facilities and learn from them as well. So I think we support both.
And about defense, since you mentioned defense, you work with NASA, the Department of War. And you also actually, in one of your posts, talked about dual use and the importance of dual use. So, as one thinks about building a business that could potentially be dual use, how do you think about the split of government customers versus private customers? And how does that change based on your scale?
So I genuinely think a good defense company, a good patriotic defense company needs to be dual use if they can. There's sometimes you can't, right? There's sometimes you're making a fuse for a missile and it's very custom and you can't be. But if you can, you need to be dual use. The reason for it is, we all hoping that actually defense is a very seasonal market, right? That hopefully we're not in perpetual wars, right?
Yeah.
Or we have bigger problems. And if you're a company that you are purely defense and you need to then absorb this seasonality, this peak in and valleys in demand, then you ended up having a huge overhead and your cost goes up, right? Because you're accounting for these changes in demand. And that's why a lot of defense companies, have become costly. That's why, a lot of weapon systems are very expensive, right? Because there are small volumes, they're a little bit erratic in terms of need. Maybe we build a stockpile and then we don't need more of it, right? Because we're in the peacetime. So I think even if you want to be a good defense company and you want to be a patriotic defense company, if you have an option to be dual use, you should be, so that you can have this, it can smooth out your need and your demand with the commercial market. So right off the bat, we decided that we want to be dual use, and we are a core manufacturing technology, so there's no reason for us not to be. It's a significantly larger market. But like with any new technology, you need to first find who is your early adopter. An early adopter is somebody who doesn't really care about cost. Early adopter is somebody who doesn't care about necessarily a risk that associated with your technology and all the things that can go wrong. Somebody who cares about probably speed and cares about the new tech, what it enables for them in terms of like doing new material, doing things in a much rapid pace than they could do before. And in manufacturing, that usually end up being defense because they have national security concerns. They're like, we need to be on the edge of making the things that our competitors cannot do, right? Or on the edge of the speed of things that our competitors cannot do. So very naturally for us also early customers were, both defense and also like, a space exploration like NASA's of the world, where they're willing to push the envelope. But right off the bat, we wanted to work with automotive, with heavy equipment. I think in 2023, we worked with more than 30 different brands to figure out what is our actually niche outside of defense and space. And that's how we landed on auto. So we always had the eye to have both.
And who were you speaking with at, say, the Department of War? Like, who's the first person to talk to?
Yeah, selling to Department of War is not easy. There is a lot of need. So you need to first identify where in this whole chain you're the most valuable. For us, ended up being in sustainment. A lot
Hmm.
of people, actually, it's kind of interesting. There's a lot of discussions around new weapon systems. We
Yeah.
talk about Andurils of the world, like they're to how they can make mesh of new weapons, drones, and things like that that are like the most recent needs in the way warfare is done. But still today, 70% of weapon system budgets is spent on sustainment, meaning that the weapon systems that you have from 50, 60 years ago, they are the ones that are actually doing the war. And when they get damaged, they need to be replaced, they need to be repaired.
Right.
And that's a significant, that's basically 70% of the
70%. Yeah.
weapon system budget. So for us, it made a very good sense to go to that area and enable, the military's ability to be able to like, hey, a landing gear door, a panel on an old aircraft gets damaged. Let's not go through a traditional route that takes us 4 years to repair it. Let's go to Machina Labs, who has a significantly more agile, faster technology and enables us. So we started working with depots and sustainment units first, but then from there expanded to the new development, new weapon development, new defense system development as well. But early customer was in the sustainment world, in the repair and maintenance world.
I am not exactly sure about the percentage here, but I do know that Indian government strategy is also very similar. So you should try to tap into India at some point as well.
Absolutely. No, absolutely. I mean, we just recently, announced a partnership with UAE. So we are
Oh,
going to
yeah,
the Middle East region. So, and it was funny, like as we were talking about it, there was conversations about like, oh, maybe the UAE region can support, India as well. And we're like, no, no, India is a massive market. We would
it
love
is.
to be able to support that directly. So yeah, definitely we have plans to work with India as well.
Yeah, absolutely. And just talking about the UAE market, you currently have two factories, right? And you are launching a third and the fourth shortly.
Correct.
Okay. So, you partnered with the Strategic Development Fund of the UAE and are planning to launch your fourth factory, I believe, there, right? So, what were the factors that you took into consideration before deciding beyond the obvious geopolitical one?
Well, I mean, yeah, obviously number one is demand, right? I think the Middle East region, obviously it's a region as we know is a huge, huge, turbulence and need for, countries to build up their defense. So we knew that that need exists, right? Especially in the Gulf states. But more importantly, I think we also looked at, out of all the countries in the region, Saudi Arabia, UAE, Turkey, we saw UAE as a place where they have an appetite for new technology. They also have a lot less restrictions around being able to hire, folks from, Europe, from US to be able
Hmm.
to work there and kind of like help us, run and and operate these facilities that we're going to set up. We had a very good partner that had very good ambitions, the Edge Group, that has ambitions to build a lot of different defense systems that we can support them. And they also had a huge need that
Right.
their current supply chain, is mostly reliant on foreign entities. So they were thinking about reshoring and bringing a lot of this manufacturing in on their country.
Right.
So all those factors together made UAE a very good option.
And they are open to having a foreign company do that for them, right?
Yeah, no, that they're open to have the foreign country do that for them. Obviously, like we're going to set up we're going to have a local partner
Right.
there with SDF or Edge Group. We're going to have a local partner in the region. But yes, I think they're more open compared to a lot of other countries in the region to have international partners.
Yeah, especially in a sector that's primarily of national interest, right? So very interesting. And obviously, like when people are in manufacturing, they think about when is the right time to launch a new factory. So how did you think about that? What were the indicators that were actually indicating that this is the right time to set up the third factory?
I mean, it's simple. Purchase orders. Right? Like, you don't want to set up something before there is intent to buy, right?
Right.
We are setting up our facility number 3 because with one of our programs,
Hmm.
we are now in qualification phase, so it's about to go to production, right?
Right.
And we know once it goes to production, we have a couple of years to get to volume, and for
Hmm.
that we need the new facility. So we had to get started sooner than later. But yeah, I mean the signal is like, once the customer commits and be like, hey, I need a lot more of these. I think that's the right time. Hopefully as soon as we can, because sometimes like, you want to make sure you account for the time it takes to set up a facility. But
Yeah.
one of the benefits that we have is that we can actually set up facilities pretty fast because our
Huh.
technology is a portable technology, so easily can
Yeah.
be deployed. But yeah, I mean, we wouldn't start a new facility until we have a demand signal.
Makes sense. And the other thing that you talk about, which I thought is a very good or simple way to think about things, is that you focus on a few processes and you do them well, right? And so, how and when did you find out that, process ABC or maybe process A is the one that I do want to go ahead with?
It's kind of interesting. I think, there's like, the process of kind of exploration and exploitation that you need to
Mm,
balance, right?
yeah.
So if you look at in 2023, like I said, like we work with like 30 different brands,
Mm,
right? So we explored a whole lot of applications for our technology. We work with automotive companies, a bunch of them. We work with heavy industries and heavy equipment, energy companies, defense companies, 30 different brands. And we did actually very small contracts with everybody because our goal was to figure out, okay, which is the one that has a, enough need, pull, excitement from the customer and, kind of urgency that, they want to use our technology. Because, as metal structures, the need is very diverse. There's a lot of people who want metal structures. You need to figure out who wants it the most, who is
right.
burning for your project. So we spent that, couple of years, 2022, 2023 to do that. But once we saw that, then we narrowed down on 4 or 5 applications where we were like, okay, these are the most important applications that we see the most amount of traction. Based on that, we define processes, right? So again, came down from market pull. You really need to identify customers that, like, if you walk away from the deal, they will be like, no, come back, right? Because there's a lot of people out there that you'd be like, hey, like they might want to do metal structures, but
Yeah.
they're not gonna die if you're not around. You want those customers, especially in early stages of a company. You want those customers where you're like, you walk away, they'll be like, no, I'll pay you more. Let's stay and let's just do this, right? So so initially go wide, but very soon you need to narrow to say, okay, like what are the 4 or 5 things I'm gonna do?
But when do you take a step back and then try and analyze, okay, do I want to increase the scope of my offering?
So I think there's 2 strategies you have. There's also one is land and grab more, right? Like,
Mm,
once you land on one application,
yeah.
it's very safe to look at that application. Let's say we make missile, structures for a customer, and we say, "Well, what else around missiles can we do that easy addition to us for
Yeah.
us, right? Well, how much more value can we capture in the current customers, right? I think that's easier ones to be done. I
Mm,
think as a startup, as an entrepreneur, I always also have like that itch to find the next big thing, not just
yeah.
a full addition. So we spend like I would say maybe 20% of our time exploring new application. Always have that pipeline of a hey, let's do $100,000 project with this customer. Let's say, like for example, somebody came to us and said, hey, I want to build this 50-foot statue of George Washington for America's birthday in 2050 birthday. And it was like, you guys
Wow.
can form a stainless. And it's like, this is a market we have never been to in.
Yeah.
But okay, that's an interesting project. It's a small project,
Yeah.
but I would love to do that to see, okay, what does the entertainment and architecture market look like?
Yeah.
Always include that like 20% ability to do experimentations. So
Right.
we always have a pulse on what might be the next thing. That might be a huge opportunity for us. But yeah, you got to be, in early days of the company, that's 80% of your work. I think as you mature, you might want to kind of like bring it down to 10 to 20% of your work.
Yeah. And I think one thing that I really liked about many of your podcast interviews, you were very consistent with one thing, which is that in a manufacturing setup, culture and team are very, very important, right? And so when you were undergoing this, process of sort of identifying what works most, how did you structure your team or how did you manage your team's goals and ambitions? And, maybe sometimes I think like people even tend to get scared, right? And that, hey, this is too much experimentation. So how did you manage that, I guess?
Yeah, it's not easy. I
Yeah.
think, first of all, I think the key is, you want your engineers and the people who are actually doing the work be as close as possible to the results and the end thing that goes to the customer. Like they
Yeah.
actually be involved with the customer.
Yeah.
So you can close that feedback loop really fast. So it's not like, some other people, some business people are talking to the customers and some other engineers are doing the work. The loop is not closed. So like you might do
Mm.
this experimentation for such a long time and no results are actually clear and nobody knows what they're doing. And then by the time you figure out, hey, we've done down this rabbit hole for too long, it's already too late, right? So
Yeah.
you want to form a small teams that work when you're doing experimentation, small teams that are working very closely with the customer, I think as a CEO, you need to be very involved with those teams,
Hmm.
to especially on the experimentation side, to
Yeah.
like really call, okay, hey, this is enough. Like we're wasting our time. Like make those decisions when needed. Um, but yeah, the first key is, very small teams, very rapid, agile, small teams. But I think, the kind of the other side of that is also just, set goals of like, what do you want to achieve out of this,
Yeah.
right? And like constantly evaluate yourself. It was like, hey, my goal was to eventually get to a $10 million contract out of this, and I would do it. That's done. That application, I don't want to explore it anymore, right? And then also set just overall goal of like, I'm not going to spend more than 25% of the company efforts on this,
Yeah.
right? You need to like set some of those parameters so that like you are not also like betraying yourself,
Right.
right? Throughout the process, and be like, hey, like maybe I'll do another one project and maybe something else comes out of it. You need to hold those lines firm. The other piece is, to your point though, the teams that do exploration are very different than the teams
Hmm.
that long-term projects that are already proven.
Right.
Um, the exploration teams are more like cowboys, right? The long term, bread and butter teams are more like farmers, I would say. Like the
Yeah.
different mentality. Like, you
Yeah.
know, cowboys love to just go explore. They're agile, they're, jack of all trades. They try a lot of things, and they like building things really fast and then move on. The teams that do long-term projects, they're much more stable. They want documentation. So you need to put the right people in each of these teams too, and they have a completely different psychological profile.
Hmm. Very interesting. So let's talk about the metrics that matter most, because your teams were obviously, as you said, very close to the customer. So what did you understand was the most important, or still is the most important metric that your customers are looking for out of
Yeah.
you?
So customers are different. Different customers care about different things, right? I think let me talk about internally, what do we care about, and then we can talk about what customer cares about.
Yeah.
I think internally, obviously, everybody cares about long term is like, what is the revenue and profit, right? But that horizon, depending on their technology, might be different, right?
Yeah.
So you work your base backward to today. So you set up your plan to be like, okay, I need to hit this level of revenue, this margin. So let me work my way back, develop a thesis on how you're going to get there. And then I think the metric you track is actually your speed, your velocity toward
Hmm.
that, right? I think
Right.
that's the metric that I cared the most about. How
Hmm.
fast are we moving toward that end goal, which might be 4 years? Let's say this program in 4 years needs to be $100 million a year. In 3 years need to be $100 million a year. Work my way backward to say, hey, we need to do qualification before that. Before that, we need to do some demo units. We need to. So you come up with the plan, and then the metric you really track is how fast are you moving through these,
Yeah.
right? So you mostly care about velocity, not the actual static goals.
Love that. Yeah.
So how fast the customer is giving you new POs, how many of the people, how many more people from the customer are involved? Like these are like metrics that I start looking at along the way that are not necessarily the end goal, because that might be a little bit too further away. But like by just seeing how many groups from the customer are involved in our weekly meetings. Like
Hmm.
those are the things that gives me a little bit of, velocity indicator.
Right.
Okay, like now this OEM, Toyota, Lockheed, is really involved, 10 times
Right.
more involved than it was 6 months ago, right? And then I think, so that's internal metric that I'm tracking. From the customer perspective, really then comes down to, you know, they have different values. Most customers care about today, still also care about our agility. How fast can we meet their goals? How fast can we deliver products to them? Less so today is still about cost, but I think that probably going to change over time, right?
Yeah.
But today is really value add for us, for the customers, is like, hey, you are 10 times faster than making these metal structures for me than my traditional alternative.
Very interesting. Because from the outside, looking in, I think people also tend to just believe that some of the traditional industries may be moving slow
Yeah.
versus fast. So it's very interesting to know that they're actually concerned about the speed as well.
Yeah. No, especially I think, if you like about defense, which is our primary customers, the world of defense is changing very rapidly, right?
Yeah.
And obviously these new conflicts, the most of the emphasis has been on, hey, how fast can we move? How fast can we get our new designs out? How fast can we increase the production of our old designs? So it's all about agility and responsiveness, which was not a traditional in a peaceful world of 1990s and early 2000s. That was not the concern. The concern back then was like how technologically advanced our weapon systems are compared to the other customers, to other competitors. Now it's more about like how fast can we actually produce both new designs and old designs compared to our competitors
Right.
in the stage.
Well, I don't know if it's a good thing or a bad thing, though.
Yeah, I mean it's one of those things. I think defense is like, you want to have your weapon system so you never
Yeah,
have to go to fight, right? But
absolutely.
without having it, I think also then you're at the risk of starting fights because then people will perceive you as weak. But I think if every country like works on their defense, hopefully then you create that equilibrium that like, hey, nobody wants to mess with anybody else because they have enough, they have the security of their, you know, amazing, excellent defense industrial base.
So at Protein, we conducted a research and we found out that Tesla has, over the last 5 years, the average of 5 years of ROIC was higher than the traditional automotive companies. And one of the reasons was that they focus a lot on COGS per unit, as well as lower, battery costs in general, right? And so I'm just curious, for a manufacturing company like yours, or in general, how should we think about building financial systems, right? Should we try to optimize for these costs from the get-go, or is it only a question for some time later?
Yeah, I think it depends obviously on your technology, right? I
Mm.
think if you're a marginal improvement, you need to worry about the COGS right off the bat, right?
Right.
Because that's the benefit you're providing. You're improving margins and it's a marginal improvement. So like, what is your cost today? If your fundamental shift, I think you need to make sure your fundamental shift is actually very high margin, right?
Hmm.
Like it enables some things that's very high margin. So you're not nickel and diming on the costs right off the bat. One of the things, was exciting to me about high mix, high volume and going into the defense and using robotics, getting rid of the molds, getting rid of the tooling was that, okay, I knew that my margin is actually going to be high, right? It was not any question that my margin is going to be bad. It's like, okay, at best case, on average, I'm going to be able to, like, even if I do poorly, I'm going to be 50%, but
Yeah.
more likely close to 70%, right?
Yeah.
So now I have room in early days to not worry about margin as much and try to either improve the tech and do some stuff that are like costly early on, give maybe discounts to the customers that are strategic so that I can
Hmm.
move forward and kind of make things happen. So for us, yes, for us it was like start from a very high margin thesis, make sure your technology makes sense for that, and then you don't worry about it early on, but over time you need to then dial it in. Like you need to start looking at, okay, all your pieces of cogs, like, Tesla is now year probably 20 or something like that.
Yeah.
And now they're starting to really worry about this. And that's a very natural thing for a mature company. But then when they started from Roadster, right? Which is a luxury product, high margin product, right? Because they didn't want to worry about, kind of like, oh, is this wheelbase is going to be more expensive? This wheel or this trim is going to be $5,000 more expensive or not? We can absorb the cost of that
Yeah.
because the vehicle is high margin. But now you're doing Model 3, it's a $30,000 vehicle. So you better make sure that like, every cent is counted for. So I think that's easier for when you have like, completely new technology, revolutionary technology, like for us in robotic manufacturing, for Tesla being EVs for the first time being mass producible and available in the market. But yes, if you're an automation company that like really your focus is improving COGS, then you got to count the COGS right off the bat.
It's also something about consumers' perspective as well. So, for instance, a lot of these luxury brands, very different segment, but luxury brands introduce very expensive, high margin luxury products first. And then, as the brand is established, they trickle down to, I'm not quite sure as to what they're called, but there's a specific term that they talk about when they introduce some lower price brands that are still, I would say premium, but not ultra luxury, but great for the overall basket of goods.
Yeah, and it's a great strategy for fundamental shift in the market. Like, you start with something high margin, you have
Yeah.
like early adopters are willing to pay a lot of money for it, but
Yeah.
then down the road, you can increase your TAM by offering a little bit more optimized version for the rest of the market.
And I know you are very particular about who's on your cap table. And the last time we spoke, you talked about the various ways of capital formation. So, how do you think about getting the right people and the right modes of capital for your company?
The capital formation strategy is tightly, coupled with your company's strategy, right?
Right.
So a lot of traditionally a tech company relied mostly on, equity dollars, venture capital dollars that are
Yeah.
actually pretty expensive. But it makes sense to do that because once you develop the technology, let's say you're developing a software piece, then, you kind of can, it's also a cash cow. You can generate
Yeah.
a lot of money off of it, but you need to do a lot of development early on. I think for companies like ours, the story is slightly different, slightly harder because we do have that technology piece. So we need to bring in equity dollars to invest in the technology, but also we need to operate factories. So there's a huge operational aspect as well where, debt maybe plays a bigger role, right? And you don't want to spend your expensive equity dollars on buying equipment and paying rent in the factories and pay for electricity in the robots, right? Like you want to make sure that, you have debt to cover your CapEx.
Right.
And also, I think, to your point around like, who do you bring in your cap table? If your technology, traditionally, like, strategic investors, like, your customers being an investor was actually like a dirty word. A strategic investor was a dirty word. Like they were like, oh, like you don't want a company to be influenced by your customers much.
Yeah.
But I think, if you're talking about a technology that the horizon of implementation is 5, 6 years, like it is in manufacturing, then I think the story changes. The narrative changes. You want actually your customers to be involved. You want your customers
Mm.
to have a stake in your company and care about your success as opposed to just see you as a transactional kind of like, customer buyer relationship, right? Um, so it was very important for me to get these alignments within the big corporates like Lockheed and Toyota, which are our customers. So they're all
Right.
investors in our company. But I think if you're going down that route, you need to make sure that you also diversify. So you're not significantly reliant on one of your customers to have a huge effect on your company or huge influence on your board. So you need to be careful to like arrange the rights and the diversity of the investors on your cap table in a way that you maintain autonomy. I know that's why we have, Yamaha, Toyota, Lockheed, Nvidia. We have this large group of strategic investors as part of our cap table. Now they're very helpful, right?
Right.
And then they can help us build long-term alliances within these companies. Also, I think for a company like ours, where has national implications, you need to also get government involved, right? I
Mm.
think there are things that we're working on that are very short term. We can work with equity investors. There are things that are slightly long term. We want to make sure the customers are highly involved. And there are
Yeah.
things that are like significantly longer term, like building industrial base for the company where hopefully you have government support and involvement, both in terms of dollars and in terms of like actual verbal support of your business. So the capital stake became significantly more complicated than a simple software startup
Right.
that traditionally was in Silicon Valley.
And you said debt. What is the cost of debt if I am to raise debt in, say, your kind of environment and scale?
I think today, I mean, obviously interest rates are still pretty high, so there's
Yeah.
always like a premium on top of the interest rate that the Federal Reserve actually charges. So right now we're like depending if a good financing, debt financing package is in, you know, below 10, 8, 9%. Not so good is like you're looking at 12, 13, 14, depending on how risky your project is and how much assets you have to back it and what kind of collateral you have. Yeah.
Yeah, this is very much like India. And now a bunch of people, high net worth individuals, have started to invest in project finance. And the kind of IRRs that are promised are actually very similar to what you're stating, say 1 or 2% more.
Yeah,
Uh,
yeah. Yeah.
so,
I think especially, yeah, it's a low risk project. You're looking at
yeah,
a couple of percent above,
yeah,
Fed rate, right? Especially if you have good assets to back. And I think that's also part of your,
yeah,
as a startup, part of your how you want to actually attack, in terms of your capital stack and your assets. Like, can you actually build assets that are easily financeable, off the shelf assets versus trying to build a lot of stuff in house and do custom things? I think that's also part of your strategy that from technology piece, of your company ties into your financing piece, right?
And I think no conversation around manufacturing today is complete without talking about AI. And so you're obviously using AI, but how and when do you actually use AI at Machina?
Yeah, I mean, at the end of the day, I think, AI is an interesting word. I think at the end of the day, customer cares about, they don't really care about AI.
Yeah.
Sometimes people do, right? Sometimes people want to be like seen as like, hey, I'm supporting AI and this is the next. But for the most part, any long-term project, it's not coming down to some kind of a competitive advantage, either lower cost, faster speed, being able to do things that you couldn't traditionally do. Those are the three categories, right? It doesn't matter,
Yeah.
right? So you can call it AI or not. If it's not one of those three things at the end of the day, it doesn't matter. So yeah, so start from there and then see if AI helps or not, right?
Yes.
In a lot of cases it does, right? Like for our case, we're enabling, kind of like design diversity. So that means our machines need to be more adaptive and that means they need to be more intelligent, right?
Mm.
Being able to easily switch from one design to another, one material to another. That means they need to have almost like human-like thinking in terms of, okay, I want to form
Yeah.
this new part out of this new material. How do I change my process parameters to form that? Instead of doing trial and error, there needs to be some type of intelligence that come up with that. So in that
Right.
case, for us is ML-based, AI-based model, machine learning and AI-based model. But it really comes down to, but the benefit even in this case is like AI means faster switch over,
Mm.
faster time to go from product A to product B, faster
Yeah.
time from going material A to material B. So we need to define that, what it means. AI itself is just like, it's a tool. But I do think right now there's a huge opportunity to make manufacturing significantly more agile using AI. I don't know. There are opportunities for cost saving, but I think the biggest opportunities are in how fast can we kind of produce products, account for agility, for changes. I think AI is going to be a big enabler there.
And you talked about a few customers or customer relationships where you've sort of integrated your equipment with their existing facility,
Yes.
which means that integration is super important, right? And so, when I speak with a bunch of folks who are working in these factories, these are operations folks, manufacturing engineers and stuff, they talk about simulation, right? Before even getting anything on the ground. So how do you or do you run simulations, right? And if so, then where do you think the simulations actually break down when they reach the ground, if at all?
I think, yes, simulation is pretty important, but there's one big flaw with simulations. One is they're not accurate.
Right.
They're
That's
always
what they say.
useful,
Yeah.
but not accurate.
Yeah.
And in a lot of cases, they're also very computationally intensive. So they take a long time to do simulations. So when we started our company, the natural thing to do was, in order to develop our process, do it in a simulated world.
Yeah.
But the problem is those two things. It was just not accurate and it took a long time. So we started actually with just empirically doing trials. And the main objective at the time was like, how fast can we do actual empirical physical trials to gather data, as opposed to, because simulation will take a long time and it's going to be
Yeah.
slow. So how do we enable our system to actually run physical trials fast? So for us, it's a combination. We started from physical trials, but now we're also spending a lot of time and effort in simulation. By the way, simulation engineers are more expensive. So like you
Yeah.
cannot really afford them early on in your journey, but maybe later on you can, right? So we started a lot of simulation work, a year and a half, couple of years ago, not right off the bat. So now we do both, because if you have good and fast simulation, then you can generate a lot of, synthetic data and,
Yeah.
and kind of make decisions in the virtual world. But we need to close the loop with physical reality, and that's why both of them are important. You need to be able to make sure that you can run physical trials and you can also do simulation trials to complement each other. I think building company on top of one or the other is actually probably a mistake, right?
Yeah.
If I had to choose, I would actually start from, potentially in our specific case, which I did, from not with simulation, start with empirical, actual experimental approach to get something out there and then add simulation to it afterwards.
And is there a system or any suggestion that you would like to share with regards to building the data set for scale? Did you put any systems in place or did your team
Yeah,
put?
we built most of the stuff in-house. We use some off-the-shelf things like, Databricks and other
Yeah.
places that allows us to do a lot of, large scale data processing. But most of our analysis and absorption stack was built in-house.
Right.
So we didn't use anything specific off the shelf, but I'm sure there are a lot of tools. But for us, it was mostly in-house. We did obviously partner with NVIDIA very early on. So using NVIDIA GPUs and NVIDIA platforms on simulation was something that we worked on very early on through this partnership. But other than that, most of the stuff has been built in-house.
And what have you, I think we've discussed a lot about the technical stuff, but I was watching something where you came across as someone who's very grateful for the opportunity that you've received in your life. And so were you always like that, or what happened? Like, what have you learned about yourself in this journey?
Yeah, I think, on I think, even though like, in the beginning we talked about like entrepreneurship not being exactly like, what I had goal in mind. I just wanted to solve interesting problems. But I do think going entrepreneurship is probably one of the tougher things. I wouldn't say the toughest thing, but it's one of the tougher things that, folks do in their life. And I think it teaches a lot about you throughout their journey because you need to be grateful for the people you work with. Because like, if you're doing well, you're going to work with the smart people that are teaching things to you every day. There are going to be times where you have to make very tough decisions, right? Potentially like reduce, headcount and in those moments, you need to both be grateful, but also like, be humble enough to know that these things going to happen and you need to make decisions.
Yeah.
So I think actually it's a very good self-discovery journey for people who have the appetite for the toughness of it. I think you will be forced to make a lot of hard decisions, which is not easy. But it has been a great experience. I've been lucky to be able to work with a lot of smart people that I learned a lot from.
Thank you so much, Ed. This was wonderful, and I'm sure that folks will learn a lot from you and your experience as well. So thank you again.
Well, thank you for having me, and it was a great conversation.
Thank you.